Okay, so this problem we're told that Erica traveled 24 miles on the Allegheny Passage, that she walked some of the time, and the rest of the time she ran. We're also told that the trip took 5 hours, and we're also informed that she can run at 6 miles per hour and walks at a rate of 3.5 miles per hour. We'd like to determine how much time she spent running. This is a typical distance, rate, and time problem. Usually in distance, rate, and time problems we have lots of information that we have to deal with. So we often use a distance, rate, and time chart based off the fact that distance is equal to rate times time. So the first thing you would want to do in these problems is kind of look to see what it is that you absolutely know for certain. So I would begin by labeling each of my categories. She traveled some distance running, and she traveled some distance walking. So first thing we want to do is we're dealing with two different kinds of distances: distance ran and distance walked. And then for each one of these, we have to figure out her distance, her rate, and her time. So we look first for what we're given, what information we know for sure. And that is that her rate running is 6 miles per hour and her rate walking is 3.5 miles per hour. Now, what we want to find out here is the time that we spent walking. The amount of time that was spent walking. Well, as we look through this chart, we don't know how far she walked. We don't know how far she ran. We don't know how long she ran. And we don't know how long she walked. But because of the relationship D equals RT, if we know how long she ran, then we can figure out how far she ran by multiplying the rate 6 miles per hour times the time. So what we have to do is pick one of those columns now, distance or time, and allow those to be our variables. Because they are asking, because they are in this problem asking for the time, I would choose to allow those two things to be my unknowns. And then because of the relationship distance equals rate times time, we can multiply through to get our second expressions now for distance. So the first thing is getting the chart set up, and then we set about trying to find our equations. So as we read through the problem, we see that it took 5 hours. Now that was not 5 hours walking, that was not 5 hours running. That 5 hours is a combination of the time that they were running and walking. So in other words, R plus W has to be equal to 5. We then see total trip was 24 miles. So what we know is that some of that 24 miles was covered by walking, some was covered by running. So those two things together would be our total distance of 24 miles. Okay, it wasn't 24 miles running and 24 miles walking. It's 24 miles. Some of it was running, some of it was walking. Okay, and now we have our two unknowns. Or not our two unknowns, our two equations. And then we can proceed to solve those two equations. You could use elimination, or I'm going to choose to do it by substitution. So I solved the first equation. For R, got R equals 5 minus W. And then substitute that into the other equation. And again, you may want to pause the video for practice and go ahead and do that. Okay, so I substituted it in, and then I start simplifying. 6 times 5 minus W. I would get 30 minus 6W plus 3.5W equals 24. Combine my like terms. I get 30 minus 2.5W equals 24. And proceed to solve the equation. Subtract 30 from both sides, and then divide both sides by negative 2.5. I get that the walking time was 2.4, and then I use my R equals 5 minus W, plug in the 2.4, and I find that the time running now was 2.6 hours. And in this case, that's what we wanted to know, was how much time they spent running. Okay, so you're going to find you're going to really need to first work out your unknowns. In this case, we actually had 4 unknowns, but because we only had 2 variables, we make use of that relationship, distance equals rate times time, to figure out to represent the other two unknowns, and then it's using information in the problem to work the problem out.